All right, so you guys are used to measuring angles in degrees. Okay, so you got maybe a 90-degree angle, 45-degree angle. Today we're going to talk about measuring angles in another unit. So, for instance, you can measure distance different ways. You can measure distance in miles or feet or inches or meters, centimeters, light years, different ways to measure distance. There's different ways to measure time. You can measure time in seconds or hours, minutes, different ways to measure. So there's also different ways to measure angles. Okay? So you're used to doing it in degrees. Today we're going to learn about radians, and we're going to figure out a relationship between degrees and radians. All right, so consider this circle. Okay, R is going to stand for the radius of the circle. So I'm saying radius, that means this distance here. Remember an important fact, the circumference of a circle is 2 pi times the radius, or pi times diameter. All right, so what is a radian? Okay, so make sure you understand the difference between these words. This is a radian. This is the radius. The radius is this distance from the center to the circle. A radian is going to be an angle measurement. All right, so let's draw this out. We have this angle theta right here. All right, so imagine this theta. I can open this angle up however big I want it. Right? I can make it a really small angle. I can open it up and make it big. I'm going to open this angle just enough so that this distance, this radius, is the same as this sector of the circle. Okay. So imagine if I open this angle up, the bigger I make this angle, the longer I will make this distance here. Okay. So this distance right here is going to be the same as the radius of the circle. Okay. So however big I need to make this angle, so that this distance is the same as the radius of the circle, is going to be this theta. And the value of this theta is going to be 1 radian. So this is R. We're going to say that theta is equal to 1 radian. So again, a radian is just however big I need to make this angle so that this sector of the circle is the same length as the radius of the circle. All right, so once I do that, now let's set up a proportion. Okay, so this length right here, this sector of the circle, if I make the ratio between this length and the entire circumference of the circle, which would be 2 pi r, that ratio should be equal to the ratio of this angle right here to the entire angle of the circle. So it would be equal to theta over 360 degrees. All right? So these two are proportional. The ratio between this length and the entire circumference is equal to the ratio of this length or this angle to the entire angle. So we have this proportion. All right, let's see what we can do with this. So I can cross out the r's. Okay, that simplifies, and I'll have 1 over 2 pi is equal to theta over 360 degrees. Okay, let's solve this for theta. So theta would equal 360 degrees over 2 pi. Simplify that, and I'll get theta equals, divide those by 2, and I get 180 degrees divided by pi. Okay, remember that theta is 1 radian. So we know that 1 radian is equal to 180 degrees divided by pi. Okay, so I asked my calculator what that is approximately equal to, and it turns out that that's about 57.3 degrees. Okay, so our radian is approximately 57.3 degrees. Okay, so again, this is an approximate number. So if this is 57.3 degrees, when you open up this angle, so it's about 57.3 degrees, this length will be the same as the radius of the circle. All right. Let's take the equation from right here. Or, excuse me, we'll get rid of this. Make a mess. All right, so from right here, let's multiply both sides of this by pi. Okay, so if I multiply both sides by pi, pi times 1 radian will be pi radians. Equals 180 degrees. All right, so this is a very important conversion factor. This tells us the relationship between radians and degrees. So that is extremely important. So pi radians is equal to 180 degrees. So extremely important. You need to memorize this. You need to know this. You also need to know how we got it, how we came up with that. All right, so let's work on converting degrees into radians. So suppose I want to convert 20 degrees into radians. Okay, so I'll start with 20 degrees, and I'm going to write this as a fraction, so I'm going to put a 1 underneath it. All right, sorry about that. So I'm going to start with 20 degrees, and I'm going to write it as a fraction by putting a 1 under it. Okay, I'm going to multiply this by 1, so I'm not going to change anything. But I'm going to multiply by a special 1 using this conversion factor. So these two are equal. Pi radians is equal to 180 degrees. If I divide anything by itself, I just get 1. So if I multiply by pi radians over 180 degrees, I'm not changing this. This is still 20 degrees because all I'm doing is multiplying by 1. Pi radians is equal to 180 degrees. So the numerator is equal to the denominator. Anything divided by itself is just 1. All I'm doing is multiplying by 1. I'm not changing this 20 degrees at all. I'm just going to rewrite it. All right. When I do that, my degrees will cancel because I got degrees on top, degrees on the bottom, so they cancel. And now I'll have 20 times pi radians over 180. So now I've converted into radians. There's no more degrees left. They cancel. I'm just in radians. So all I need to do now is simplify. 20 over 180. That will reduce to, let's see, pi over 9. All right, 20 divided by 180, that's 2 over 18, or 1 over 9. Yeah, so that'll reduce to pi over 9 radians. And let's write it like that. That would be the same thing. So 20 degrees is equal to pi over 9 radians. All right, let's go the opposite direction now. So this time, let's convert radians into degrees. Okay, so I'm going to start with pi over 12 radians. And again, I'm just going to multiply that by 1. Except this time, I'm going to want radians on the bottom and degrees on the top. So since I'm starting in radians on top, if I multiply by radians on the bottom, I'll be able to cancel those. So 180 degrees is equal to pi radians. So all I'm doing is multiplying by 1, not changing anything. Radians cancel, pi's cancel, and I'm left with 180 over 12 degrees. And all I need to do is simplify that. Let's see, 6 will go into both of those, so that'd be 30 over 2 degrees. 30 over 2 is 15, so that'll be 15 degrees. So pi over 12 radians is equal to 15 degrees. All right, so let's take this circle, as good as I can draw a circle anyway. It's not a perfect circle, but pretend this is a perfect circle, centered at the origin. Okay, so we put this circle on an XY coordinate plane. The center of my circle is at the origin. Okay, here's how we're going to measure angles on this circle. So we're going to start here at what I would call 3 o'clock. And we're going to rotate in a counterclockwise direction. So all the way around the circle like this. And so if we start here and we measure this angle, how many degrees would that be? No, that would be 90 degrees. So let's call this, so that's 90 degrees. We started here at 0 degrees. So we started at 0 degrees. We rotated around 90 degrees right here. That's that. What if we rotate all the way to here? What would that be? Well, that would be 180 degrees. What if we start here and we rotate all the way around to here? So this pointing down. So all the way around to there. Well, that would be a 270 degree angle. What if we go all the way around the circle? So we went all the way around here. That, of course, would be 360 degrees. Okay. On this circle, we're going to pretend that we can keep going. So what if I go all the way around the circle and I go another 90 degrees? Well, then I would be at 360 plus 90, that'd be 450 degrees. Right. So in our little circle scheme here, 90 degrees is going to be equivalent to 450 degrees. What if I go all the way around the circle twice? That would be 720 degrees. So all of these degree measurements are going to be this equivalent on our circle. 0 degrees, 360, 720, and then you could keep going forever and ever. All right, what about if we go halfway between this? So if we do this angle, I'm making a mess there. All right, so if I do this angle right here, halfway up to 90, that would be a 45 degree angle. All right, 45. Let's write it out here though. And that's 45. What if I go here? So I went 90 degrees and then 45 more degrees. That would be 135 degrees. What if I go here then? So 180 and 45 more. 180 plus 45 is something, 225. What if I go all the way around to here? So I'll start here at 0, go all the way around. That'd be 270 plus 45 more would be 315. So you see how that works. All right, let's write all these degree measurements in radians. Okay, so we start off with 0 radians. 180 degrees is how many radians? Well, that's pi radians. So this would be pi radians. If this is pi radians, what would 90 degrees be? You don't even have to work out the conversion with arithmetic. You can just tell what it is. 90 degrees is half of 180, so in radians it would be half of pi, or pi over 2. What if we go all the way around the circle? So 180 degrees is pi. So if I go all the way around, that would be 2 pi radians. What about 270 degrees? So I'm going pi radians, and then another half of a pi radians. So 1 pi plus half a pi would be 3 over 2 pi, or 3 pi over 2 radians. 3 over 2 is 1.5. Okay, so these are very important. You need to have these measurements ingrained in your mind. This is 0, pi over 2, pi, 3 pi over 2, 2 pi, all the way around the circle. All right, what about the 45-degree measurements? So we could work those out algebraically. We could do the conversion like we did a few minutes ago, but it's really easy to just tell in your head. If this is pi over 2, then if this is half a pi, then this would be a quarter of pi. So this would be pi over 4 radians. And so on. You can fill those in the rest of the way around the circle.